For the next phase of this vibration sensor design challenge, which is this sensor here, I'm going to instrument the Stirling engine and see if we can't have it monitor the vibration with a little microcontroller. And what we're going to do is actually use the generator that's on the Stirling engine to run the microcontroller. So here's the microcontroller, and you can see it has a display. It has 3 thermocouples to monitor the temperature. It has a little microcontroller here. There's a circuit here to monitor the current coming into the module, and there's also, of course, voltage monitor so that it can monitor the voltage and the current coming to the device. And then here's an analog input that I'm going to run the vibration sensor into. So let's see how that all goes together. So I have here a little circuit that I built to condition the power from this generator. So there's a Schottky bridge rectifier in here and a little capacitor to smooth out the generator voltage. And I also have a USB connector in case I want to run this off USB instead of the generator while I'm fixing or adjusting the program in here. So this power connector plugs onto the device here like this, and the vibration sensor plugs on over here like that. And just for now I'm going to run this from a USB power like this, just to see if it works. And here's the power switch down here. So when I turn this on, you can see it starts up Stirling engine monitoring, and then there's 3 temperatures here, the thermocouple 1, 2, and 3, and then there's a vibration reading, and then there's a millivolts coming from the power supply. In this case, it's this USB power. It's 5.5 volts, and it's taking about 14 or 15 milliamps. Now I also have up here a button which allows me to turn on the backlight for the display, and that backlight consumes another 15 milliamps. So if I turn that on, you can see that the milliamp reading goes up to 29 or 30 milliamps, and that's going to test whether or not this generator can really supply 30 milliamps. I believe it can do 14 milliamps, but we'll see. And I'll just show how this is all going to be packaged. I have to turn it off to do that because these cables have to be threaded. Okay, so this is the package that's going to hold the card, and this is really mainly to try and have a place to put all this cable that I have from the various sensors, so that I don't have to cut it. So hopefully I can jam it all into the bottom of this package here, and the computer sits on top of it all. It snaps in, but I won't snap it in until I've put some cables in there. So this cable comes out the bottom here, and it's just going to sit in there. And the cable from the Stirling engine is going to come in here and plug onto that. Polarity doesn't matter because it's got a bridge rectifier. Now, to thread these cables, I've got 3 thermocouples that have to be threaded through, and they're coming out to the Stirling engine, and they're going to plug into the card. So let's just thread all three of them. And the final one, this one still has some heat shrink on the end here, which I can't put into the flame, so I'll just use it to monitor one of the other temperatures. Maybe I'll cut some of this video out so that it doesn't bore everybody silly. But basically that's the cable, and I'm going to route it inside here and try and pack it down so that it can fit. Okay, the fire is going. I've packed all that wire underneath this card. I have not turned it on yet. I'm going to wait until this gets up to a pretty good speed because it can't generate enough voltage if it's not going fast. So one of the thermocouples here, the weld broke, so I just twisted the wires. Maybe it'll work, maybe it won't. Let's see if that can turn on. Wow, it's running. And we've got, you can see thermocouple number 2 is up to 200 degrees. Vibration is sitting at about 86% of full scale. But the voltage is low. It's only about 3.8 volts, which is barely enough to run this thing. So I've got one thermocouple in the fire and it's at 313 degrees. One thing I wanted to try, of course, is to load it. We're at 14 milliamps, 4.5 volts. Well, that slows it down, but it's still hanging in there and driving the backlight at 26 milliamps. So that's a win. Everything's working. We've got our 3 thermocouples working. As you can see, these cylinders don't get too hot, so they're at 28 and 25 degrees. Even though when that thermocouple was in the fire, it was right up at several hundred degrees. It's at 381, 416, and I'm burning the insulation there. That's right in the fire. So 423. Oh, get that thermocouple out of the way. You can see the vibration sitting at 72%. Now I'm going to try something else to reduce the vibration, but we're able to read it here, so that's all good. Let me see if I can blow out the flame and let it just coast down. Let's see when it really drops out here. 3.7 volts. I'm going to turn it off at, there we go. It dropped out at around 3.7. So, when I'm moving this around, it's hard to keep the thermocouples from contacting the movement here, and this Kapton tape isn't very sticky anyway, so but once it's all locked in place, it should be fine. Anyway, the next thing I'm going to do is going to stick it in this heavy duty vise and see if that will reduce the vibration. Hang on a sec. Okay, I've locked it in the big vise there, and we're about to turn it on. Almost hot enough. Just by feeling it, that vibration is almost nothing. But maybe the vibration sensor says something different. Let's turn on. So the vibration sensor is still saying about the same, 70%, but it's definitely much quieter, and it doesn't feel like it's vibrating as much, but you know, it can be at a higher frequency, which I can't really feel too well. So there we go, the vibration's coming down at 50%. So here we have a complete package. Notice that the generator is driving this diode down here continuously, the LED down here. And when I turn on the backlight, let's see now, right now we're running at 4.3 volts, 4.4 volts. I turn on the backlight, wow, that dives. So it's down at 3.8 volts. But there are 4 LEDs in the backlight here. But interesting experiment, that's what it's all about. Well, I've got a nice little instrumentation package here. It does need some work to mount all this, maybe on a big piece of butcher block or something, to really stabilize it. And I think we're running out of alcohol, so I'm going to blow it out. And I'm going to turn this off when it hits 3.8 volts. Oh, it's at 3.7 and still hanging in there. Overall, it actually generates a little bit more power than I expected. It can do 25 milliamps without too much trouble. It does reduce the voltage, but that's interesting to know. That's the only way to find out, is to do it. Okay, I've hooked up the scope as well as my little monitoring circuit. And we have to turn the power on. There we go. So that's about 80 millivolts peak to peak. And I'm going to hook it up with the vise and see how that works. Okay, that looks like it should be just about fast enough to get going here. Not quite. There we go. So we can see that the vibration is down a little bit, just like we had with the sensor on here. It's down to just under 60 millivolts peak to peak. So the vise does make quite a big difference. Just see if my hand makes a difference, but not too much. So this has been a very interesting project. Lots of different things, lots of different aspects to explore. And I'm pretty happy with the way things have turned out. Lots of fun in the process. Now just have to figure out how to write it all up.